Okay, yesterday we have discussed about partial differential equation of first order. Okay, the equation of the type, suppose f of x, y, z, a, b, f of x, y, z, x, comma, y, comma, z, comma, a, comma, b equals to 0. This is the partial differential equation of first order. Okay, where in case of partial differential equation, we consider two independent variable and one dependent variable. Okay, at least in partial differential equation, it contains at least two independent variables. Okay, so in that equation, suppose we consider the first order partial differential equation, and so this look like a suppose f of x y z f of x comma y comma z comma a comma b. Okay, where a and b are, but a and b are some functions of x and y only. In some cases it may be constant also. Okay, and we have discussed about various type of partial differential equation, that is suppose semi-linear, linear, non-linear, quasi-linear, and so on. Okay, and today we will discuss the Lagrange method for solving partial differential equation. Okay, actually we have discussed some problem yesterday, and in that what we did, we eliminate a and b. By eliminating the constant a and b, we can form a partial differential equation. Okay, first you have to um, write the equation in form of z. Okay, the z means you have to write the equation in forms of the dependent variable. Okay, so here we consider that z as a dependent variable. So in that example, we find del z del x, okay, and del z del y, and after that by eliminating a and b, we get the required equation. Okay, and today we will discuss another method, particular method known as Lagrange method. This is introduced by mathematician Lagrange. So according to his name, it is named as Lagrange method, and Lagrange method is used to solve uh, first order partial differential equation. Okay, suppose an equation of the form P, capital P, small p plus Q equals to R. So it is not right in actually uh, x, y, z in form. Okay, where P means what? P means what? Del z by del x. Okay, and Q is what? Del z by del y. Okay, so to solve such type of equation, we use the Lagrange method. And working rule for this is the linear. Actually, this is a linear partial differential equation. Lagrange method is used to solve linear partial differential equation of first order. Remember this one. Lagrange method is used to solve linear partial differential equation of first order. Okay, it is not in use for suppose semi-linear or quasi-linear. Okay, quasi-linear means what? If suppose A and B are in linear, A and B are linear, A and B are linear. The constant A and B are linear, but if suppose A and B are function of x and y only, then we say that it is semi-linear. Okay, and linear means what? The degree of the uh, partial differential coefficient is the degree must be 1, and there is no such term like suppose the product of two suppose independent variable. This type will not come in that equation. Okay, this type of equation is called linear partial differential equation. And so we consider the first order linear partial differential equation. Suppose it is look like as this one, capital P plus Q equals to R. This is the given equation. Okay, and you have to write the Lagrange auxiliary equation. Lagrange auxiliary equation, that means this one, dx by capital P plus dy by capital Q plus dz by R. In the third step, suppose you have to consider two independent solution of this equation. Okay, these are actually working rules. How can we solve this type of equation using Lagrange method? First, the given equation is this one. It right in this form: capital P plus capital P small P plus capital Q small q equals to R. And after that, you have to write the Lagrange auxiliary equation. and Lagrange auxiliary equation is this one. Dx by p equals to dy by q equals to dz by r. Okay, and after that you have to solve this one by using the well-known methods. Suppose let this one u x y z equals to c1 and v x y z equals to c2 be two independent solution of this equation. And after that you have to consider this one u x y z x y means x y are independent variable, z is dependent variable, which is considered as c1. C1 is any constant, and similarly we taken another function v is a function of x y z where x and y are here also independent variable and z is dependent variable. These are two independent solution of this equation. Okay, this one is what? This is the Lagrange auxiliary equation. In the fourth step, the general solution of this one. The general solution of this one is written in one of the following three equivalent forms. Phi of uv equals to 0, then u equals to phi v and v equals to phi of u. That means you have to integrate. To obtain the general solution, you have to integrate this one. Okay, see an example, then it will be clear. Suppose type 1, there are three types of equation. Suppose first we consider type 1 for solving this type of equation. Okay, type 1 for first type of equation look like as suppose dx by p equals to dy by k equals to dz by r. Are you understand? Hello? Hello? Hello?
Yes, ma'am.
Are you understand? Hello?
Hello, ma'am.
Actually, remember this one Lagrange. We have to Lagrange method um, is used to solve linear
Yes, ma'am. Not clear.
linear first order partial differential equation. Okay, first remember this thing. Lagrange method is used to solve first order linear partial differential. Okay, first remember this one, and it is used. The method is this one. Working rule is this type of. First, you have to consider the equation look like as this one. Okay, after that you have to find the Lagrange auxiliary equation. Okay, Lagrange auxiliary equation is this one. Remember this one. dx by p equals to dy by q equals to dz by r. Okay, after that you have to consider two functions of x, y and z where x and y are independent variable and z and z are dependent variables. These are the some independent solutions. Okay, the fourth step you have to integrate this one to obtain the general solution. Okay, and there are three types of equation. Okay, see the equation of the type this one dx by p equals to dy by q equals to dz by r. Suppose consider this equation ap plus aq equals to z. Okay, the given equation is this one. Okay, see this example. Solve this one a p plus a q equals to z. If remember this one, if small p and q arise, then remember that you have to use Lagrange method to solve the equation. Okay, if small p and small q are arise, then remember that you have to use Lagrange method to solve that particular equation. Okay, understand? Hello, are you understand or not?
Yes, ma'am.
Remember this one, if p and small p and q are rise, then what you did, you have to use Lagrange method. Okay, and see that here small p and q, this one is z. So Lagrange auxiliary equation is what? Dx by p. Here p is what? Capital P is, see this equation. A into p plus q equals to z. And this one will be a p plus a q equals to z. Here tell me, here capital P is what? Hello? Hello.
Yes, ma'am.
Yes, ma'am.
Tell me, see the equation this one. A P plus Q equals to Z. And this is equals to A P plus A Q equals to Z. Now tell me here what is the value of capital P and capital Q?
A A ma'am. AP.
A, because the equation is look like
A.
as capital P small p plus capital Q small q equals to R. Okay, here A P is
Yes,
what?
ma'am.
P is A, P is also A, and Q is also A. And auxiliary equation is what?
A.
Dx by P. This remember that Lagrange auxiliary equation is this one. Dx by P equals to dy by Q equals to dz by R. Okay.
Yes, ma'am.
This is the Lagrange auxiliary equation. So dx by p. So it is like as dx by a. So a Lagrange auxiliary equation for this equation is what? Dx by a equals to dy by a equals to dz by 1. Okay. First, after that, you have to take first two members. That means this one. Dx by a equals to dy by d. First, you have to take these two terms. After that, you have to take first and third term. After that, you have to in the last step you have to take the second and third term. Okay, first take the first and at first take the first and second term. After that, take the first and third term, and the lastly you have to take the second and third term. Okay, remember that this is the actually method. First, take this one. If we take dx by a equals to dy by a, then this one will be what? This one will be look like as dx minus dy equals to 0. Okay, if we take
0.
this one, these two terms, okay, then what we get dx minus dy equals to 0. Okay, now you have to integrate this equation. Okay, after integrating we get this one. If we integrate this one, integration dx, that means what? Integration 1 dx, so it will be what? Integration dx is what?
Mm.
Integration of dx is what?
X.
X, so it is x. And integration of dy is what?
Y.
Y, so this one x minus y equals to c1. Okay, so this is the solution. Okay, this is the independent solution. Okay, then you have to take first, I take the first and second term. After that you have to take second and third term. Okay, dy by a equals to dz by 1. So it will be look like as this one. If we take these two terms, suppose dy by a equals to dz by 1, then it will be what? Dy minus a dz is 0. If we take this second,
0.
suppose if we take this one, first you have to take first and second term, after that you have to take second and third term. Okay,
Mm.
then if we take second and third term, then it will be what? Just cross multiply this one, then what we get?
Multiply
By minus a
A DZ.
d dz. Okay, dy minus a dz is equals to what? 0. Okay, so it is look like as this one. Dy minus a dz equals to 0. Then you have to integrate this one. Okay, if we integrate dy, then what we get? Integration of dy will be
Y.
y, and integration of a dz is what?
Is it?
Az, because a is constant, so it will be a into this. A is az, and this one will be c2. Okay, understand? And
Yes, ma'am.
lastly you have to take this one. First, first and second term we have already considered, and second and third term also considered, and last we have to take second and third term. Oh, sorry, it's second and third term is also
No.
considered, and first and last term. Okay, first and
Yes, ma'am.
last term. Understand? If we take the first and
Yes.
last term, then it will be what?
Dx equals to a dz.
Dx equals to a dz. That means dx minus a dz is 0. Okay,
0.
so it will be look like as this one. Here, first and second. Suppose if we take dx is this one, then it will be what? Dx minus a dz is 0, and it is look like as what? Y minus a dz. So it will be like as x minus a z. Okay, these are same. So the general solution is what? Required solution is this one. Phi of c1 comma c2. Phi of c1 comma c2. So it is look like as this. These are the independent solution. These are the independent solution, and the required general solution is what? Phi of u comma v equals to 0. Here u is what? U is this one, u is this one, and v is this one. Okay, so this one will be c1, phi of c1 c2 equals to 0. So it will be this one, where phi is any arbitrary constant. Okay, understand? Are you
Yes, ma'am.
understand? And see this equation also. You have to now we consider first type. First type means what? It is look like as pp plus qq equals to r. Okay, we consider this actually type of equation is that one. Suppose you have to consider here first type. Okay, so see this equation, twice p plus thrice q equals to 1. These are the given equation. So here capital P is what? For this equation,
Capital P, ma'am. 2.
capital P
2.
2, and capital Q is what?
3, ma'am.
Capital Q is 3, and R is what?
1.
R is
1.
1. So auxiliary equation is what? Dx by T. So auxiliary equation will be look like as dx by 2 equals to dy by 3 equals to dz by 1. Okay? Process is same. And take the first two equations, first two members.
Yes.
Okay? After that, take the first two members. Then what we get? 3
X
3dx minus
minus 2
3dx
dy.
3dx minus
2 dy
2 dy
equals to
equals
0.
to 0. Okay, first take the first one, then integrate this one. If we integrate this one, then what we get? 3dx. So it will be what? Thrice x. Okay, if we
X.
integrate this one, then value will be twice y equals to c1.
Y.
Understand? First
Okay, ma'am.
take the first two term. After that, take the last two term. First and sorry, second and third. Okay, if we consider the second and third, then what we get? Dy
Uh,
minus price dz equals to 0. dz
0.
dy cross multiply this one. Dy minus
Yes.
price dz is 0. After that, integrate this one. Okay, after that integrate By integrating this one, what we get? Y minus thrice z equals to c. Okay, understand? These are the independent solution, and the required solution is what? Phi of c1 in comma c2 equals to 0, where phi is any constant.
0.
Understand?
Yes, ma'am. Yes.
And see this equation also. Solve this one. Y, this one.
Y Z P.
Y z p plus twice x p equals to x y. Okay, these are the second type. Here see that here R is what? Product of two functions x and y. Okay, in the previous two example, R is what? R is 1. R is constant. Here also R is constant, and in this equation also, this one is what? Only z. This is only z.
Yes.
Okay, this is only z. So here R is what? R is 1. Okay, but here see the second type equation. Here solving for type 2, for solving this one, dz by r. Actually the auxiliary equation is this one. For all type of equation, auxiliary equation is this one, dx by p equals to dy by q equals to dz by r. Okay, but we see that in some cases R is constant. In the previous two example, R is constant, that is R is 1. But here see that R is what? R is the product of two function x and y. Okay, understand? So
Yes, ma'am.
here see that here P is what? Capital P. For this equation,
Capital P is X
x,
X P X Z.
x, z. So the Lagrange equation is what? Auxiliary equation dx by xz equals to dy by q. Here q is what?
Y Z.
Yz. And r is
R
r is
is R is what?
r is
Z.
here. Tell me r is what?
R is product of X and Y, ma'am.
Product of x and y. So it is write as dx by sorry dz by xy. Okay. Now first take the first two equations, first two fractions, this one. Then what we get? This one is see that x dx by xz equals to dy by d yz. So if we take z as common, after that we can cancel this term. Okay. If we consider first, you have to consider the first two terms. Okay. Then it is look like
Yes, ma'am.
that dz by x equals to dy by y equals to 0. Now you have to integrate this one. If we integrate this one, what we get? Integration of dx by x. It will be, that means 1 by x. 1 by x dx.
Yes, ma'am.
That means that is what? 1 by x dx. Integration of 1 by x
Log
dx is what?
X is log.
Log x. Okay, log x minus, so similarly this one will be log y. If you have equals to c1, so it is look like as x by y equals to c1. Okay,
C1.
after that taking the last two fractions. First take the first two terms, after that take the last two terms. First two term, last after that take the last two terms. Then what we get? Last two terms. If we take the last two terms, this one will be dy by yz equals to dz by c1 y square. Because here see that the last one, this one dz by yz equals to dz by xy. Okay, dz by xy. Here see that from this one what we get, x equals to what, c1 y. Okay, xy equals to c1, so x is what, c1 into y, then you can put this one. Okay, yz equals to c1 y square, so it is look like as this one. Because so, here we does not consider dx by xy, because this one is what, this one is dz, okay, not dx. So you have to eliminate x. Okay, here also see that dy by yz. Okay, so we are
Yes.
trying to eliminate z term from here, because here this one is dy, not dz. So in that term,
This
we want to eliminate z, and here also we want to eliminate x, because this one is here, these are what, dy and dz. So in that term we have to eliminate x. Okay, here because there is no term arise like as dx, so in place of x we have to put c1y. After that we get c1y dy and z dz. Now it is easy to integrate. Okay, reason is that one, the direct we, because here we want to eliminate x, because of here what, here the dx is not here. Okay, so we want to eliminate x. Okay, after that you can integrate this one. Integration of c1 is constant, so it will be uh, come outside, so c1 y dy, integration of y dy means what, y square by 2, and similarly z is what, z square by, and this is the required equation. Okay, required solution. So general solution is what, phi of c1 comma c2. Here c1 is what, x by y, and c2 is where phi is any arbitrary function. Okay, are you understand?
yes, ma'am.
Here see the third type. Solve the partial differential equation of this type. Thrice x square sine of y plus twice x. See this type. Try to solve this one. This is your homework. Y minus twice p equals to thrice x square into sine y plus x. This is your homework. Try to solve that one. Okay. Write this one. Write this equation. Here capital P is 1. Capital Q is what? Capital Q is, here capital Q is
Yes, two.
2, and R is what? Thrice x square into sine of y plus twice x. Okay, try to solve that one. And here let me discuss about the third type. Dx by p equals to, this one form is same, but try to solve here this type of equation. Here p is, see this one, mz minus ny plus nx minus lz equals to this. I have given you some homework in the previous class. Are you did it? Where you did it? In the last class also I give you some uh, homework. Try to solve them. Okay, if you come across any doubt, tell me. Then tell me. But first you have to try. Okay. And write this question also. Try to solve that one. Here see that this type of equation nz minus ny. Here see that here P is what? Mz minus Ny and Q is Nx minus Lz and R is what? Lx minus Nx. Here see that P, Q and R in all the terms these are multiple of some Mn. Okay, here first for this one also here no X is there. Here these are some multiple of some others. Okay, so for this type of equation first you have to this one take LCM. Directly we cannot integrate this one. Okay, because here see that this one will be, if we use the cross product then what we get nx into dx minus lz into dx. Okay, directly we cannot integrate this one because these are function of z and this is dx. Okay, so in that situation first step take the LCM. Okay, first sorry take not take the LCM, first step add is fraction by this one. We add x dx plus y dy plus z dz. After that just add all of them. Then the equation will be look like as this one. X dx plus y dy plus this one. The denominator will be 0. So it will be what? It will be look like as x dx plus y dy plus z dz equals to 0. Now you have to integrate this one. Now you can integrate that term. Okay. After that, if we integrate this one, that will be x square by 2 plus y square by 2 plus z square by 2. Okay. So the required equation will be x square plus y square plus z square equals to c1. Okay. After that, this one is a first this is a first independent solution, and after that to get the another solution we just multiply each term by L, M and N. Then we get this one look like it. If we multiply first you have to multiply x, y, z and in the second step you have to multiply L, M, N. Only because of here see that because we cannot directly multiply this one. If we directly multiply this one, then what we get n dx. For the first one, it is okay, but in the second term, see that it is the minus lx dx. L sorry lz dx because this is z and this is x, so we cannot integrate directly. Here
Yes,
also we just multiply x, y and z. In the second step we multiply to get the another independent solution. We multiply by each term by L, M and N. That we get this one Lx plus M dy plus N dz because L, M, N are constant. So equation is this one Lx plus N y. After integrating we get this one is C2. So these are the solution phi of C1 comma C2 equals to 0. Okay, and try to solve this equation. These are the third type for this is the third type of equation. X into y minus z into p. Try to solve this one. Right? It is like a homework. Right? This one also. X into y minus z into p plus y into z minus x into q equals to xy divided by x minus y divided by x. Okay, take this one. Here P is this one, Q is this one, and R is x minus y divided by x. Okay, write this one, this equation also. Hello? Hello?
Hello, ma'am.
Write this equation also
Okay, ma'am.
and try to solve it. Okay? This is that third type of equation. Okay?
Equation.
Yeah. Solve exercise 2 and exercise 1. I think yeah, it is exercise 1. This one. Exercise 2 also. Solve the partial differential equation p minus twice q plus 2. Try to solve that two problem. Okay? So I will stop today.